Region 6, so this is wider Europe. We welcome you to this first session as part of a new lecture series where we aim to bridge the gaps between the research, operations, and administrations, a gap that we often find it difficult to bring research into actually practice. So as you saw in today's invitation, the session will promote research projects that will then be presented and discussed with the panel, and there will be a QA session also afterwards with possible for asking questions. I hope we stay on time and that we leave enough time for that. Today, it's my colleague Murat Altınyola, who you already heard, from the Turkish Meteorological Service, and myself, who will chair this session. So I'm Jutta Thielen del Pozo. I work at the Joint Research Center of the European Commission, and we are both members of the working group. And we are very excited about kicking off this new series. I'd also like to welcome Adina Portu, our chair of our working group, and Natalia Bergi, who is here at the moment, a bit behind the scenes, but she's helping us from the WMO Secretariat. Let me say a few words on the logistics. There were already questions in the chat. So as you saw, the session is recorded. So if you stay, you agree to the recording. The participation to the session is restricted to a targeted audience, but the recording is made available to on WMO's media channels afterwards. So there will be a much wider outreach than what we currently have in the meeting. Please keep your microphones muted, your camera switched off when the panel is speaking, and we all come back together afterwards when we have the QA session. So why are we here today? Today we have the actual inaugural lecture that features the XAIDA project. XAIDA stands for Artificial Intelligence for Detection and Attribution of Extreme Weather Events in Europe. And following the summer and recent climate reports, an extremely timely project. XAIDA is an EU-funded Horizon 2020 project. It was launched in 2021, so it is ending. It's coming to the end of its term. And that's an exactly great moment to discuss with the project leader and the key stakeholders, how the project evolved, developed, and how the output can really help us to prepare for extreme weather events. I'm very curious and excited about this session. So our keynote speaker is Professor Dim Coumou. Dim is Chair of Climate Extremes and Societal Risk at the Vrije University of Amsterdam, and he's Chief Science Officer at Beyond Weather. His expertise is really extreme weather and the role of global warming in extremes, atmosphere circulation changes, and the seasonal to sub-seasonal predictability. So exactly the window that we need to look at. He also pioneered the use of novel AI methods to gain new scientific insights and to improve the predictability of extreme events. And so with that expertise, Dim, I think you're really the perfect project leader for the XAIDA project. So without further ado, I want to hand over to you for a short presentation. So Dim will, for the next 12-15 minutes, present to us the objectives at the project. What were the objectives at the outset? What's achieved at the end? Then we will follow with a panel discussion, and we will introduce the panelists after Dim's presentation. And then at the end, there will be some time for QA. You can put comments and questions into the chat, and we will pick that up afterwards. So let's go straight into it. Dim, the floor is yours.
Yes, thank you very much, Jutta. Thanks for the kind introduction, and thanks also, Murat. Let me share my slides. Right. Thanks for the kind introduction, Jutta. So, my name is Dim Coumou. So, as Jutta said, I'm a professor at VU Amsterdam. I'm looking into extreme weather and also applying different type of AI methods to gain better understanding of extreme events and also better predict these type of extremes. So that's what I will be talking about the coming 50 minutes. So that has also, of course, been the prime aim of the project XAIDA. I'll focus a little bit on S2S predictability, which happens to be my area of expertise. By the way, great to see so many people online and also some familiar names. It's really nice. I hope to stick within the 15 minutes, Jutta, but if I go too long, feel free to cut me short. Anyway, this slide is just kind of summarizing some of the extremes that we've seen last summer. And to be fair, basically every summer you can build such a slide because we've seen these very high impact extremes, especially in the summer season, every year, again and again. And the reason is that global warming is really having a strong impact in driving heat waves and also extreme rainfall events. Right, so this shows we saw a very active wildfire season in Canada, early heat over Europe already in June, and then especially in Southern Europe, Spain and Portugal, we saw these wildfires. I happened to be my holidays in Portugal and was quite a dramatic wildfire season in that country. And then again, we've seen these flood events, for example, in Texas and also in China. So it's obviously very important to understand the drivers behind these type of extreme weather events, and that is really what XAIDA is all about. So the central research questions that we set out at the beginning is, how are extremes changing? Or the detection question, what is the role of anthropogenic global warming on these extremes? Or if you like, the attribution question, and what can we expect in the future? Projections, both long-term projections, but also shorter terms predictability questions. So that is the central question for XAIDA. Well, these are some of the institutes that have been participated, 16 in total. So it has been a rather large research activity within Europe, starting 2001, and we're finishing February. And well, as I said, global warming is having a strong impact on intensifying heat waves around the globe and also these extreme rainfall events. But there's still a lot of questions that we do not understand very well. One such question, for example, is that heat waves over Europe are increasing faster than elsewhere, and climate models do not capture this upward trend. So this is shown here. This is work by Robert Foutard and colleagues. And it shows the trend in the temperature of the warmest day of the year over Europe, and you see very strong trends over northern France, Belgium, Netherlands, Western Europe. And the units here are what we call degrees C per global warming degree. So how strong is this trend per degree of global warming? And what you see is that for this boxed region, for every degree of global warming, we see a trend of almost 3.5 degrees in the observations, right? And if you compare that to the models, you see that they have much smaller trends. Actually, only 1% of the models reach such very high level of trends in these heat extremes. And when you actually dig deeper into these models, we learn that they do so for the wrong reasons. And so this is a real concern that, well, we see these very strong upward trends in heat waves over Europe, and the climate models do not capture this. So something is missing. And this is not only the case for heat waves over Europe, but this is more widely around the globe. And this is a figure that came from this paper by Tiffany Shaw, and also many authors from the XAIDA project contributed to this review paper. And here we're compiling and comparing, looking at all the model observation discrepancies around the globe. And what we're seeing is that in many regions, the observed trends are really going outside of the climate model range. And this is a growing concern. And often this has to do with related to dynamics of the climate systems, things like Taylor connections, Rossby wave, and circulation changes. And we know that climate models have serious biases in these type of processes. So there's the hope that AI or data-driven methods can help us better understand and overcome these type of discrepancies. And of course, in recent years, certainly also since 2021. So since the start of XAIDA, there have been very rapid developments in AI. So these are new tools that are becoming available to climate scientists. And when it comes to short-term predictability, up to say 10 days ahead, AI has really been a game changer in recent years. And this is a figure which I find quite striking. It's from ECMWF, and what it shows is basically on the vertical axis forecast accuracy on different lead times from 3 to 10 days ahead. So 100% would be a perfect forecast. And what is shown is how the NWP models, numerical weather prediction models from ECMWF, have steadily improved over the last 20 years or so. But then in recent years, you really see a jump in that forecast scale, and that is due to the new AI models that have come online. So that is AIFS for ECMWF, but there's a number of other, sometimes called foundation models, that are doing very well for predicting on these timescales. I mean, actually, this figure should come with a bit of a disclaimer. What you should be aware about is that this is a scale score on a global scale. There's been some recent literature which has actually come out of the XAIDA project, which shows that for forecasting extremes, they're maybe not so good, these foundation models. But for example, and this is from the Microsoft Foundation model, which is called Aurora, in their paper that was just published in Nature, it shows for hurricane tracks, at least for this particular case, that Aurora is doing a much better job than the state-of-the-art operational systems. So it's clearly that these type of foundation models are doing something well, and we should learn what exactly. And I think that is really important. Good. Now coming back to XAIDA, so XAIDA has been very much having dialogues with different sectors, including the energy sector. So also asking what is really needed for the energy sector. And what is a clear need is that the energy sector over Europe needs supply and demand forecast, good information on that as early as possible. And the reason is, of course, that the European energy market is rapidly moving to more and more renewables, and that generates a lot of volatility on the grid. And at every time, supply and demand needs to be balanced on the grid. And well, what's shown in this work, and this was by Emmanuel Rouge and colleagues, is that weather regimes have a dominant influence of energy supply and demand, and therefore also energy shortfall. So to explain, to illustrate that, if you look, for example, at Scandinavian blocking, which you see here, that is associated with very low wind over the Nordic seas, as you can see here, including the North Sea, which is very important for wind power in Europe. And at the same time, very cold conditions, which is, of course, driving demand. In fact, what you see is that the risk of days with very high demand is nearly tripling during such Scandinavian blockings. And the risk of day with low wind energy is more than doubling. And this is really amplifying energy shortfall risks. And this is true for all these red countries within Europe, right? So Scandinavian blocking across Europe is causing problems for the energy sector. The good news here is that weather regimes, including Scandinavian blockings, have predictability on S2S timescales, at least 4 to 5, 6 weeks ahead. And that has come, for example, this figure was generated as part of XAIDA, which shows that in this case, NEO minus, the negative NEO state, has strong lead-lag relationships up to 46 days ahead with MGO phases, right? And these are really quite strong relationships, so up to 6 weeks ahead or so. And it's actually a larger body of literature which is now showing that weather regimes up to 6 weeks ahead have predictability. We're also learning that NWP models tend to have difficulty capturing this predictability. that there is hope that AI models can do better here. And one way to approach that is to train an AI model to correct NWP models. In this case, we're working with EC46, and then come to an improved forecast. So this is one way to do what we call a hybrid forecast. So in this particular studies by Giem van Straten, we looked into this region, Western Europe, and we're looking at the probability that the 2 meter temperature is exceeding a particular quantile threshold. And then we look at week 3 to 6, so really on the subseasonal time scale. And yeah, so our architecture, so it takes the input, the probability as provided by EC46, and then we train this AI to make a correction on that probability. And what we find is that this works actually very well for relatively low thresholds. So in this case, a quantile of 0.5, the median. Then you can see here with this scale score plot that the corrected probabilities have a scale score which is also almost twice as good as the uncorrected ones. For higher quantiles, we lose that scale again, and we think that is because we're simply running out of enough sample size here. Anyway, for the median, exceeding the median 2 meter temperature at weeks 3 to 6, we really managed to get quite a strong boost in scale. Then, of course, we want to understand where is this coming from. So what is the EC46 missing, and what can the AI model do better? And here, explainable AI methods come in very useful. We've been working with so-called SHEP values. These are widely used methods in AI, for example, in image recognition problems, as you can see here with the bird. So you can basically ask like which pixels were most important for the AI to make the decisions that this was a do-witcher. And then you find the beak and the eye and the general contours of the bird that made it decide for this particular classification. So this is widely applied in this context, and you can use exactly the same tools to look at what were the important reasons for creating a certain forecast, right? And that is what we do here. So here on the horizontal axis, we have more than 2,000 individual forecasts, and they're not chronologically ordered, but we're clustering them according to what type of corrections were made to the forecast. And what turns out to be very important is this tropical West Pacific dipole, as you can see here. And whenever this dipole is in a positive state, the AI is making an upward correction. So it's increasing the probability of warm temperatures over Europe. And whenever it's in a negative state, the dipole, it's making a downward corrections. So it's saying like the estimated probability from EC46 is too high, and you have to reduce that probability. And then you have regional precursors, North Sea SSTs, and this fourth one that can either strengthen or dampen this signal that originates from the tropical West Pacific. And we can actually interpret this as an actual Taylor connection pattern, right? So it's not actually we had a follow-up paper, which is this 2025 paper, where we dig deeper into the actual processes, and we really see a Rossby wave emanating from this dipole region, reaching all the way to Europe and creating warm temperature anomalies. So this way it's an explanation how XAI methods can find new Taylor connections and also highlight biases in the models, because the ECMWF model lacks this Taylor connection as the AI needs to apply or correction to it. Good. Another example of such Taylor connection research is shown here by the work from Raed Hamed. And Raed has been working with so-called causal discovery methods. So this is also an AI technique which enables you to extract causal Taylor connection relationships. And he's been looking into how ENSO variability influences North America and South America, and particularly soil moisture in important breadbasket regions. And what he's basically finding is that persistent La Niñas drive soybean harvest failures in both North and South America, and therefore present a real and major risk for agriculture prediction. And the reason is that the US, Brazil, and Argentina combined account for 80% of global production. So if both North and South America fail, then you have really a problem on the markets. And right, so it's first of all important to disentangle these Taylor connection, what is driving drought in these regions and crop failures. And second, he's been looking into a specific case, which happened to be 2012, which was such a persistent La Nina. And we indeed see crop losses in both Argentina and US. And then we reproduced this event in a pre-industrial climate, so a cooler world, and a 2 degrees C world, so roughly 1 degree warmer than present day. And what we find then is that the warming intensifies the impacts from the droughts on crops. So the droughts, in terms of soil moisture droughts, are not really different in the 3 climates, but in warmer climates, the impact of that drought on the crops is much more pronounced. And we found that you roughly see production losses roughly double with every degree C of warming. So serious risk. Good. By disentangling these Taylor connections using causality tools, that's giving us a solid understanding of how Taylor connections impact crops, and that really paves the way for impact-based forecasting using AI methods. That's what we've done in this particular paper. So we're training models to use sea surface temperature patterns of the Pacific to forecast soy yield in the US and also Brazil and Argentina. And it actually works very well. In this way, you create what we call actionable forecasts. So they're accurate, they're early enough, so we can already do a forecast in February of the harvest around October. So that's really early enough to enable early action. It's impact relevant. So we're not forecasting meteorological variables, but we're forecasting impacts, in this case crops. And it's physically well understood, so we can really have a fair amount of trust in this type of forecast. And that combination can really make a forecast actionable. And that's also one of the reasons why we've operationalized this. And a key outcome of XAIDA has been the launch of the climate tech startup Beyond Weather to bring such type of forecasts to different parts of society. And what you see here is that the operational crop forecast product of Beyond Weather has a much smaller forecast error compared to current operational systems, which are provided by the USDA, the US Department of Agriculture, and are also coming much earlier, right? So the Beyond Weather forecast comes in February. USDA only releases its forecast in August, where there's, of course, very little one can still do. Good, so I think this is a very interesting way for impact-based forecasting. What Beyond Weather right now is working on is further developing its prototype technology to fine-tune AI foundation models to excel really in European S2S forecasts, particularly aimed at the energy sector. So what is fine-tuning? Well, I already, in one of my first slides, introduced these new foundation models, Aurora, AIFS. We also have, for example, Climax, which is a relatively simple foundation model. And these foundation models are trained on very large data sets. They also large deep learning models. And The idea is that they learn the foundational processes of the climate system. And then what one can do is, in a fine-tuning exercise, you continue the training of these models, but you change the weights for particular location, extremes, variables, and time, such that the training focuses on to become really good in a particular forecast exercise. So in this case, Europe and variables that are relevant for the energy sector of Europe. Good, so that is the prototype technology. The preliminary results show that this indeed works. So you can really improve forecast for the weather regimes, as shown in this plot, and also for near surface temperature, as shown here. And I think that is an very important development. Small groups working on this, but that really ultimately would allow really tailored forecasts for specifically time, regions, and variables for clients. Good. So I would like to wrap up here with some concluding remarks. And if you're interested in that, please also read our policy brief that we wrote together with the CLINT project. So the CLINT project was the sister project of XAIDA. They were both funded from the same Horizon call. CLINT is also finishing this year. And we wrote together a policy brief for the European Commission, and where we summarize the opportunities and also the risks of AI applications in climate science. So very shortly, the opportunities. Deep learning are very effective for short-term predictions and have major potential for the longer time scale, starting with ST-West, but also beyond. XAI can reveal new sources of predictability. I've gave some examples of that, right? So I think that's, of course, important for a better understanding of the climate system, but also to have trust in these AI-driven forecasts. Integrating impact data enables actionable, impact-based and tailored forecasts. And the fourth point, the low costs democratizes climate services. I haven't discussed that in my presentation today. But once you have trained an AI weather model, whether it's a foundation model or maybe a smaller scale AI model, once they are trained, they become very low costs to operate, right? So number of NWP models require massive HPC infrastructure, and there's a lot of qualified personnel to operate all of that, and that's typically why national Met offices are able to do that, but hardly any other players out there. And now with AI, this is changing, and I think this is this means, of course, that we have different startups that are providing such services. I think that is by itself a useful development, and what's also a potential nice application that also in the global south, where Met offices have fewer resources, can also operate these kind of models. Then the challenges, lack of physical constraints, a major issue really, making attribution particularly challenging. The reason is attribution is ultimately always about physical understanding. Limited generalization to past and future climates, making counterfactuals unreliable. That is again making attribution with AI methods quite difficult. And point three, limited transparency and sometimes weak scientific grounding can erode trust in climate services based on AI methods. And I think that is, we see many startups that promise risk products by combining different data set and using different AI methods, and not always the climate science basis is very solid for these products, and that we should be wary about that. Okay, that's it from my side. So happy to take questions, of course, and looking forward to the debate.
Yeah, thank you very much.
Over to you, Jutta. Yeah.
Thank you very much for almost being on time. Took a bit longer, but we will speed up, no problem. What we will do now, we will start with the panel first. So reserve your questions. If you have questions, please put them into the chat so that they're not forgotten. And as we said, it will also afterwards be promoted on social media, where also there's still possibility for interaction and discussion. Thank you very much for a very interesting presentation, Dim. I'm sure it triggered a lot of interest. Let me come back to the speaker. So what I suggest is, as we introduce the panelists, please switch your cameras on. So we start with Marie Ekstroem, who's the Assistant Director in the Climate and Sustainability team at the global reinsurance broker Gallagher Re. So Marie is, by education, a regional climate scientist with more than 20 years of academic and governmental research experience. I think that's relevant. And she works with different teams, and she gives guidance to matters related to climate risk in the reinsurance sector. And she also supports, the in-house catastrophe analytics team on climate change adjustment, robust data, and information choices. Welcome very much, Marie. Next panelist is Sarah Q from KNMI, the Royal Netherlands Meteorological Institute. Sarah is specializing in attribution since 2015, and I think what we saw in this talk also highly relevant. She's a PhD in dynamical meteorology from ETH Zurich, and she's a leading member of the World Weather Attribution Initiative. And in the XAIDA project, her role is also coordinating the communication, and I think that will play a role here also in this in the talk, in the panel. Sylvie Parey is currently a senior researcher at EDF in research and development. Again, for over 2 decades, she's been contributing to the EDF Research and Development Research Program dedicated to climate change in collaboration with the Institut Pierre-Simon Laplace. And there are 2 extreme events that kind of influenced really her scientific career. That's the 1999 windstorm and the 2003 heat waves. A reminder that extreme events have happened in the past and will happen in the past, but of course, understanding how this changes with climate change is one of the big challenges here. Bünyamin Sürmeli, he's a journalist. He's both journalist and meteorologist. He's got a degree in atmospheric science and meteorology from Istanbul Technical University, and he's now editor-in-chief for meteorology in Haber Global, which is a Turkish online news portal. And on his LinkedIn profile, it says that his long-standing experience and passion in weather forecasting led to also radio contributions on the topic, and they gave him the nickname, the man who smells the weather. So let's see if AI will help us to smell the weather better in the future. And so let me kick this off with a question to Marie. Marie, in the private sector, the insurance risk and financial perspective, where do you see the most immediate valuable operational product that XAIDA would deliver to you and help you to quantify climate-related risks?
Let's thank you for that. Yeah, thank you for that question, and thank you for the presentation. It was really good to get a nice overview. I think there's always a generic challenge in transferring academic knowledge into operational practice, because operational practice is quite constrained and there's sometimes little headroom to make adjustment, and it can be quite disruptive. But I do think there are some opportunities, and as Tim mentioned, there are already quite a lot of startups and private entities that act in this space. I think in terms of example, where the easiest uptake would be, or the most natural would be, the parametric insurance. So this is a type of insurance where payouts are triggered by an event, it's sort of certain event-specific conditions being met. Unlike traditional insurance, where you kind of payout is dependent on the kind of incurred cost, also incurred loss. So it's different types of tools being used for this. And the parametric, because it's data dependent and many of the processes are relying on public data sets, it's easy to see how this could be scalable and automated using AI stepping into various processes. so the risk for parametric insurance or for a policy holder of a parametric insurance is basis risk. So this is kind of when the loss doesn't it doesn't kind of meet the payout, and there are negative and sort of positive aspects to this thing. So there's negative sort of when a loss occurred, but a payout wasn't triggered. It's automatically sort of triggered because of a certain level of magnitude event was supposed to happen, but sort of either the modeling was wrong or it didn't trigger, like the station data was not appropriate. So similarly, it can be positive risk that payout is triggered, but there wasn't actually loss incurred, and that's maybe happy for the policyholder, but less good for the market as such, and will probably trigger some sort of regulatory insight, sort of interests. So there are, of course, roles for the predictability for parametric insurance, and I think here, as Tim said, a key role for projects like this is not just the product itself, but the framework of assessing the robustness about how to use this type of information and educating the sector about what type of questions to ask around what is a robust product. So that's probably the most relevant.
Okay, thank you, Marie. Indeed, I think you alluded to that, Tim, now the point of how to get the trust back of how to get the trust into the products and to keep it. And so I put almost the same question to you, Sarah. So we've seen the view of the private sector, some hesitation a little bit, but opportunities also from the more operational point of view. What do you think that XAIDA offers you as a research project, in addition to what you do anyway already at the operational sector? How do you see the potential uptake and the uptake opportunities? Where would you see the biggest added value and gains?
Yeah, thanks for the question, and it's very nice to be here today with all of you. And yeah, indeed, it's not easy to get products taken up by climate services, by institutes such as KNMI, especially given the diverse range of tools and results that are coming out of XAIDA. It's difficult to generalize, but leaving that a bit aside, then I see a massive benefit is that these are cutting edge solutions. So the XAIDA results will bring those institutes up to the forefront of science. They're already there, but they can remain at the forefront with these solutions, and they're available free of charge. And of course, with support. The XAIDA project has not yet finished. The scientists are still active and very willing to help the institutes get these products on board. And there's no need to start from scratch. There's always, XAIDA has developed these products already. There are institutes already investing into AI, but here the products have already been developed for you. Of course, there is a need for handover and training and tuning to the specific needs, but we hope that these products will be used widely. And finally, even if institutes don't choose to take on the exact tools from XAIDA, we really believe that they're going to be inspiring and will motivate institutes to look further into AI solutions and develop products inspired by XAIDA.
Thanks, Sarah. So, I mean, that's a very good point. Now that the research projects are developing new tools, but then they come to the end, like now XAIDA is coming to the end. But then to really make the transfer to operations, it would need more support in some way. Dim, how do you see that? Are you ready to deliver the support? Is XAIDA ready to deliver more support? How do you see the uptake, supporting, fostering the uptake, I should say?
I mean, it's always a bit of a challenge. Yeah, let's be fair about that. I think we maybe have to differentiate a little bit between the different products that XAIDA produced. So on one hand, we have the operational attribution products. For example, Klimameter. I didn't highlight it in my presentation yet, but this can do operational attribution. And there's a couple of these attribution methods that have been developed within XAIDA. I think there is actually quite an important role for Met offices to pick that up and operationalize that. And I'm already aware and partly involved in such new operationalization projects. So I think in that sense, there is continuation there, and the ECMWF is also interested in having such operational products. So I think in that sense, there is this jump from more fundamental science to bringing this to operationalization. Then the other products are really more in risk and in predictability, right? And that is there. I think there are probably more market products that commercial players can play a role in operationalizing this. And then those would have to be picked up, right?
Mm.
And I guess, in terms of coming back to your question of support, I think all the scientists that I know that are involved in XAIDA love it when their methods get operationalized, whether that is by a Met office or whether by some other identity. So they are always willing to support that. On the other hand, time is always limited. Scientists are busy and they have their projects and they have to deliver on their new projects. So typically, to make it work, in my own experience, is to have a new project that works, that combines scientists with operational institute to operationalize things, right? And that in XAIDA, that was not the aim. It was the aim to build or to develop tools that are useful for climate services, but not yet operationalize those, right? It was in a way one step before, if you like.
Thanks, Tim. I think it also shows, I think also a good point that there's a responsibility of the Met services also to go to the research and pick things up and turn it around, and the role of the private sector. I hand over to Murat.
Thank you, Jutta. And I want to ask a question to Sylvie, a representative from energy sector. Sylvie, energy systems have to make decisions weeks to months ahead. What concrete opportunities do you see in AI-based solutions that XAIDA offers to increase your planning horizon?
Yeah, thanks for the question and thanks for the invitation. So, as you said, and as Dean said too, in the energy sector, we are using weather information at all the time scales, from weather forecasts, the near short-term weather forecast for the operation of the electricity system, to the S2S forecast, or even decadal forecast for a better planning month or even years in advance. And we are also using climate projections to inform climate change adaptation and to inform the design of new assets. So when we have to protect or deal with very extreme events, we need to be informed soon in advance, so that we can be prepared to face those events. And if the new AI techniques can allow for longer for being informed longer in advance than we can currently be informed with weather forecasts or climate predictions, then this will be of very large interest, because it's always better to be prepared to face some extreme situation than to be to face it and have to deal with it in real time. So a better information or a longer term information from what could happen is very useful. And another interesting part is the attribution, extreme events attribution, because once the changes in some extreme events, changes in frequency or in intensity, has been proved, then we need to adapt our processes or operational processes so that we can or installations so that we can be resilient to those extremes and their new characteristics. So definitely we need we are very interested in such results, and it's a useful information to consider in our operations.
Thank you, Sylvie. And I want to turn back to Dim for 1 minute. Will XAIDA be able to readily to deliver on these expectations, or do you see research gaps before products can be fully operations and produce the added value Sarah and Sylvie mentioned? For 1 minute, please.
Yeah, thanks. So yeah, I think so we've been collaborating with the energy sector for 4 years, and that really I learned a lot about what is needed. I've also been impressed by that the energy sector is really taking a lot of steps of getting more prepared. On the one hand, they have to, well, they're really forced to, because there's so much more renewables coming onto the European energy grid. So that forces them to become really involved in anticipating weather, anticipating extremes, both on shorter time scales, but also long-term risks. Yeah, what XAIDA can deliver. So I think what XAIDA and also projects out of XAIDA have now shown is that we can do with AI, we can do better weather regime predictability for the European region. And we can do that up to 6 weeks ahead. Weather regimes are dominant for supply and demand, and therefore for shortfall risks and for risks of blackouts, as well, we've seen also this year, for example, in Spain and Portugal. So I think the fundamental science shows this now, and we also quite well know with which tools we can do it. We still have to actually do it, and we have to then operationalize this. So that is not something that XAIDA will do, but that is then in the hands of either Met offices or climate tech startups, right? Like Beyond Weather.
Or service providers, let's say.
Yeah.
Thank you very much, Tim. This is the end of our first round, and on the second round, I would like to talk about the tackling of roadblocks. We heard about the potential benefits and added values of the AI solutions. Now let's talk about roadblocks. What's really holding back operational adoption of the AI in dealing with extreme events, from forecast, detection, and decision making? First, I want to ask to Sarah. Sarah, what is immediate operational data or other issues come to your mind?
Yeah, thanks. It's always a challenge, and I think very simply, it's hard to convince institutes to try something new. As I said earlier, many weather and climate services are already exploring using AI, so they've got the researchers already on it, or they're not there yet, but they already have procedures that work for them and they produce what they need already. So yeah, we need to come in then with a new project and actually probably present it to them. And then they need to overcome that barrier and the investment in time that's needed to understand the benefits and to realize what's available. Also, stakeholder needs can be very specific, so they need to fine-tune the XAIDA output to their individual needs. Plus, nowadays, there's many more methods available for detection and attribution, so it can be difficult for them to see what's needed and what's best. So even if they're aware of the tools, they need a means to understand them and when it's appropriate to use them. And another very important point, which Dim alluded to earlier, is that KNMI and other meteorological services are dependent on public trust, and the same institutes are responsible for issuing warnings, weather warnings, and so they need people to trust them in order to respond in the best way. So yeah, given that these services are not actively looking for external support, we need to convince them that they will benefit from XAIDA's advances.
Thank you, Sarah. You finished? Sorry.
Yeah, maybe just to add that for those particular institutes, then we would advise a slow uptake where they can really test the products and see that they're performing as they wish, and that they can continue to have that public trust.
Thank you very much. You give very good insight from the meteorological services side. And now I would like to ask to Marie to give some insights from the insurance sector insights. AI solutions are scaling up very quickly. Do you see hesitation for integration of AI solutions in your sector before solid research solutions have been tested?
Yeah, so as a broker, we license quite a lot of different CAT model tools and various tools to use to sort of in the NatCat context. And as a general principle, I think it would be very sensible to kind of test a method to see that it can add value before you use it, certainly because it's kind of used in a real world context when we use it for pricing. So you wouldn't want to use something you don't have confidence in. And we have already in-house had sort of teams who've been evaluating AI tools in an extremes context. And wouldn't be familiar with all the type of evaluations that's been done, but so what I've heard is sort of what Dim mentioned before. When it comes to extremes, some of these tools have maybe not met the expectations, so we sort of haven't gone along with it. But as a AI concept, that is not in itself an issue, I think, as long as it's sort of demonstrated to have value and it's sort of constrained, you understand what it's been trained on and what it can do. We in-house use AI or machine learning techniques as well when we develop our own solutions. So, but I think that a big roadblock, it's so where this information would sit and how you would use it, because as I mentioned, most insurance companies and reinsurance companies, unless they're of a certain size, would license these tools and the catastrophe model, which is used to link a hazard to pricing. And these tools have a hazard component. And this hazard component, there's a lot of investment going into producing these, and they are meant to represent all the physically plausible range of that hazard that could exactly sort of be used many sort of thousands of years of simulations. So if that tool doesn't capture what could possibly happen in a seasonal forecast time horizon, there's something fundamentally wrong with that hazard component. And then it becomes a trust issue with the vendor companies that why doesn't your tool already capture this? So that is sort of almost a discussion around how would vendor companies take up the type of information used rather than maybe the insurance and reinsurance companies who use these tools. So it kind of sits in that space. And other things around, which is interesting around predictive skills and hazards, is that insurance companies are not disaster risk management companies. So if there's high predictability for a hazard, then it's a guaranteed loss. So that's something to think about as well. So that they are sort of largely private companies in this sector, and they have a role in society. But there is that balance as well, because for something to be insurable, it needs to be a random event, sort of, and that's like sort of hasn't that uncorrelated. So it's not straight like this kind of predictability and acting on that information. It's slightly different in an insurance context. So that's worth thinking about.
Thank you, Marie. I think you are living in a totally different world. Thank you very much. And what about the energy sector? Now, I would like to give the same question to Sylvie. In your sector, do you see roadblocks or barriers to move forward with the integration of AI solutions, or rather the opposite of having to use AI, even if the outcome is still uncertain?
Well, in the energy sector, our colleague who operates the system are already used to use weather prediction, numerical weather prediction products in their business, and they have developed tools and chain of tools in order to take this information into account. And any change in these types of chains of tools or in these processes can be very long, because between the decision to make a change and the effective use of new information, this may take a very long time, and so those types of decisions are not made very easily. In order to enter such a change process, they need to be convinced that the new information, the new tools can give much better information than the previous ones. So this needs to, they needs to be confident in the outcomes of the new tools, and they need to be convinced that this will be a very game changer in their practice. And so that's why it's probably not very easy. But on the other hand, we can probably use AI information together with other types of informations, like numerical weather forecast, for example, in expect aggregation mode, for example, in order to balance between different types of information. That's maybe another way of taking those new AI products into account.
Thank you very much, Sylvie. Again, I want to turn back to Dim. Were you aware of these roadblocks or barriers when you started the project? And how do you plan to tackle them towards the end of the project?
Yeah, thanks. Yeah, no, this is an interesting discussion. I guess at the start of the project, I was more naively thinking like, if our tools provide better information, or maybe at an earlier time of the climate system, then that will be useful for all kinds of end users. Now I'm learning that this is not always the case, and that end users have very specific needs. So I think, for example, for some end users, it is the case. Thinking, for example, of TSUs, so the energy network operators in Europe. They are very used to working with forecasts on different timescales and risk models. And if you provide them just a bit more better information or a bit earlier, then they can better manage their operations, right? So it's of immediate benefit for them. So that is TSOs, sorry. But then if you go to other players that have more financial interest, it really depends on the business model that these, like Marie was highlighting, like an insurance business model, actually benefits from unpredictability of the event, right? If I can summarize it that way. So if you get more predictability, that is not necessarily a good thing. And I mean, if you talk to traders, commodity traders in energy or also agriculture, they care actually less maybe about what the climate system will do and more about what the market will do. And what the market will do depends again on what do the markets look at, and they look at EC46 most of the time, which is the operational state of the art. So this is the ECMWF 46 days ahead forecast. So you get these counterintuitive things like people asking, can you give me a forecast of the forecast more earlier? And that is real beneficial then for a business model. Again, anyway, maybe that is a bit long answer, but it has been very, that has been quite eye-opening for me that these needs are very different, right? And it's not simply providing more information is not enough.
Thank you, Dim. And finally, let's talk about the final end users, the citizens. Trust in institutions is essential, in particular in extreme events when decisions need to be done fast and citizens need to act. And this is also a communication issue. As a meteorologist and as a journalist, I would like to ask this question to Bünyamin. As a journalist, how you see public perception shifting with AI-generated results for the accountability institutions have here?
Thank you. It's an important question. Indeed, trust in institutions is vital. In this context, artificial intelligence brings both great opportunities and big responsibilities. The XAIDA project is a strong example. It's bringing together many European research institutes and climate experts to better understand extreme events with the help of AI. Their open resources like science briefs and case studies are useful not only for scientists, but also for decision makers and the public. This kind of transparency builds trust. However, using AI also creates new challenges. Many people don't understand how AI works. If you don't explain clearly, people may doubt the results, even when science is strong. And that's why communication is key point. We must explain complex methods in clear language. Institutions should be honest about what AI can or cannot do. We also need a clear responsibility. If an error occurs, who will be responsible? Citizens need to see that institutions are willing to fix error and improve AI-based systems. As journalists, we can help this process by asking hard questions and helping explain uncertainty. With responsible and transparent communication, I think AI can support and develop public trust. Thank you.
Thank you very much, Bünyamin. There should be more journalists as a know and understand the science like you, I think, for increasing this clear communication. Thank you very much. And this is the end of the second roundup. But I would like to ask a quick follow-up questions to each of the panelists. We can start from Dim, but this is only one sentence, each of you. If you could remove one barrier tomorrow, what would it be? Yes, Dim.
Sorry, can you repeat, Murat? Sorry.
If you could remove one barrier or one roadblock tomorrow, what it would be?
Much more global data to train our AI models. We don't have enough data.
Thank you, Dim. Very good answer. And Sarah?
Yeah, something many of us have deep down, and that's that our curiosity should overcome our resistance to try something new.
Thank you. And Marie?
I could wear different hats here. I'm going to wear a practical industry hat, which on a topic that we have touched, sorry, this is more than one sentence, and that is support. Unfortunately, I think a lot of uptake is determined by availability of support. So if a lot of analytics who might not be climate scientists are asked to take up climate-based knowledge, then that is a big roadblock. So support is critical for uptake.
Thank you, Marie. And Sylvie?
Well, I would say rely on decadal predictions. and the better explainability and the ability to go by on what has been seen, so to anticipate unseen situations.
Thank you. And Bünyamin?
I would remove the lack of training for journalists on how to report AI-based climate findings responsibly. And this is a new territory. We need better tools, briefings, and cooperation with scientists to report clearly, avoid exaggeration, and explain uncertainty without undermining trust.
Thank you very much. And we finished our second round. Now I think we have some time, Jutta, for the questions and answers. Could you collect some questions from chat?
Yes, I did. And thank you very much for a great discussion. I'm sure we could be discussing this one whole afternoon, so maybe we should make this actually more a workshop than just a 1.5 hours or 1 hour and 15-minute session. We have a few questions in the chat. Let me reformulate them, or not reformulate, to summarize them. One, I think I would like to ask to Sarah, and that's it's been more a comment, and it's also been kind of touched upon a little bit. So it's by Paulo Ruti, and he mentioned the speed of AI. So maybe a bit for Sarah and to Tim. So it's the speed of AI and how quickly this is developing. So the question is how to deal with the speed in the AI development, and can operational services compete with the Google services of this world that may have, second question would be on data, but to have more data and more capacity to develop them. How do you see that?
I think that's a real challenge because, as Dim said, now that these tools are becoming available and are free, then anyone can pick them up and use them, preferably people with some expertise, of course. But then that will challenge the leading institutes who currently have responsibility for warnings, for insurance, and so on, who need that to be trustworthy. So, yeah, it's just a large challenge. I think the best way is for those institutes to go ahead as they do with their standard practices, but at the same time, simultaneously, to be investigating the new techniques, as we see ECMWF is doing, UK Met Office, and also KNMI. So yeah, simultaneous investigation, but to be aware that other companies are going to be producing results which may interfere with what they actually want to communicate.
Thanks. I think this we will pick up in our scientific forum, the regional scientific forum that we held in November in Prague. Also, there will be a session on that. But coming back to the speed and the data, there's a question also on the availability of data, but also the I need to read it, kind of the AI readability of the data. Dim, how much effort did you need to put in your project to make the data that is available accessible so that you can use it in AI? Is there a heck of a post-processing, or is there a role to play for commercial services?
Well, maybe if I can respond a bit to the earlier question, like,
yeah,
how can you compete also like to big tech, right? And the developments are going very rapidly, and it's sometimes hard to keep up. And right now, I guess the reality is that, Europe compared to, American big tech does not have the resource. So I do think that is an important role for Europe to also build these resources to keep up there, right? And that we can also train these bigger models. So I think that's an important aspect. The other one is also that it's not necessarily a competition, right? A company like Google, but also Microsoft in the past, they're building very useful tools that others can use and can work with, right? So I think it's And then I think the real challenge is to turn these type of tools into very useful climate services and products, whether it's risk products or forecast products. And that ultimately also requires a lot of climate expertise, local knowledge, if you build it for Europe, for example. Yeah, so I think there is certainly an important role to play. Sorry, I know that was a bit more on your first question response. Do you want me to respond on the second one too?
Quick? No.
Yeah, I mean, I think that was more to the data and where they were. I mean, I think over the last 5 years, over the lifetime of XAIDA, also the availability of data and working with large data set on supercomputers has become much easier, and that infrastructure has become much easier for scientists to work with. Well, like 5-10 years ago, we would still download the data and work locally. Now we work on big machines, and we train our models there. So I think that these steps have been very important. So I'm not sure if that's answering the question, but there's a lot of data. The data is open source, and we have the right environments in terms of HPC to work with.
Well, it's good to know that the meteor data is available, or whatever satellite data is made available in an already regional format. What we find often in administrations that other data, big data, are not in the format that we need it, right, or is too fragmented, and that may take a lot of effort. There are many also technical questions in the chat. It'd be great if you could maybe answer some of them also in writing. Just take a minute after the meeting, because we will not have so much time. We had one question that before we wrap up is, will you give some, let me find it now. Will you give some training to the, no, let me find the question. Do you foresee any to cooperate with the WMO Training and Education Division for organizing some regional training sessions on the use of the new tools? So do you foresee, is that kind of foreseen as part of the project, or would your project stakeholders consider holding such capacity building sessions?
Yeah, I mean, at this stage, we have not planned any capacity building activities. I do like the idea, so I would be happy to discuss that.
Okay, so maybe
Jutta,
yes,
if we have time, I can answer this question as a coordinator of one of the regional training centers of WMO. I think in this issue, regional training centers should be proactive and approach to this kind of projects to organize some trainings and to ask them if they can take part in this kind of trainings. Thank you.
Thank you. Yes, we can give that. I hope Natalia can bring this up in the WMO meetings that they have. There are so many more questions. One that I would be really interested to ask, but I think we will not have the time. One was on the role that physical models play as AI models emerge. So what will be the role of physical models? Will they become less important if we work with black box models on AI? But maybe that deserves a full different discussion afterwards. So as I said, we will have a scientific forum in Prague, 4th to 6th of November. You can join us there for full sessions where we can drill deeper into that and then have a whole morning to discuss this. Murat, are we closing our inaugural session on this
Yes, we can close the session because our time is finished, and now the capacity development panel of the World Meteorological Organization will start in 2 p.m. Maybe we can mention about the next lecture. The date is not defined yet, but please follow us. In the next lecture, we will host the Climate Europe 2 project. again funded by EU Horizon Europe. It supports and standardizes climate services in Europe and beyond by enhancing the integration of climate science into practical applications to aid decision making and policy development. Thank you very much.
Thank you very much all for joining us and having stayed with us. Thank you very much, Dim, for your presentation. Super interesting, and to the panelists also to bring the different angles that the research covers here, from the private energy sector to the operational aspects in picking up this research and making us move faster in the prediction of extremes, which is very important, and not least about communication issues, how we bring this all to the citizen. Thank you very much, and I hope I see you at the forum, and hope to learn more from your projects. And all the best, Tim, in closing and going the final deliverables and moving on to continued projects on this. Thank you very much.
Thanks, Jutta, and thanks, everybody. Very nice discussion.
Adina had her hand up. Adina, did you want to say something?
No, just wanted to, or just very short, colleagues, thank you very much to both you and Murat, as also to our guests for the first lecture, which I really consider a success. We had 105 participants, the most in this session. So thank you very much, Jutta and Murat, and also to all our guests, Tim, Sarah, Marie, and Sylvie. Thank you very much.
Thank you.
Thank you to Adina, who's the chair of our working group, for all support and who's been super busy this week. So thank you for joining anyway for the lecture. Thank you very much.
Thank you very much. Really.
Bye-bye. And thanks,
you.
Natalia.
Bye.